Over to you.
Um, Thank you, sir. Hello, I'm Sanketh. Today we are in a session called ML Hands-on. So before I actually start with ML Hands-on, let me just give you a brief. Am I audible? Mariam and Masiha, right?
Yes,
Yes,
you're
okay,
audible.
fine.
Yes.
Okay, thank you. Um, Let me share my screen. Okay, hope the screen is visible. So before I start, I just want to show you uh, the gestures of how actually like how ML is implemented. So if I tell you to imagine I can control Spotify with my hand, what would you think at the first instance? Uh, will we have an interactive session or I can keep speaking on my own? Anything is fine.
So you are saying
So
that
you are saying that
you will be able to
you will be
control
able to control
using gestures, is it?
using
I
gestures, is it?
can, right, I can control the playback of the music in Spotify with just my hand gestures. So let me show you. And this is just a hook I designed so that I can keep you interacted here. So this is, I'll take you through the application later on, but let me just,
Gesture spelling.
Gesture spelling.
oh, sorry. The application build. So I'll just show you with just our hand gestures. I can be controlling the playback. Obviously, I have linked my Spotify Worth application with this. So this is. Can you see the camera
Yes,
here?
yes.
Yes,
Nice.
yes, nice.
Yeah.
Yeah.
Okay. So I have already mentioned this is just for me. We will have an interactive hands-on as well. So one palm says play. So one palm. Can you hear the song?
Yes,
Yes.
Right.
Yes.
yes.
So we have two palms is equal to pause. If I raise my two hands, the song stops. Okay, let me play the song again. The song is playing. We have Michael Jackson in the background. So let's increase the volume with thumbs up. Okay, it's at the max. Okay, it's I have just trained it in the start. So uh, volume up and down. There's some slight difference, but that's okay. Three fingers is previous. Okay, first I'll please. We have next song and one more piece. We have one more song and three hand gesture. It takes me to the previous song. Three more hand gesture. It takes me to the previous song, and I'll just show you the Spotify so that I have not automated anything. Like it's not some recorded stuff, so it's happening. It's happening in live. So peace again. We got the next song playing. We got the next song playing. So now this was just the starting of Spotify. Now what if I just minimize all the screens? It's too much cluttered. I have browser open, I have VS Code open, I have Cloud open, I have Spotify open. It's open. So let me just minimize everything. So what I'll do, I'll just connect my fingers and one second. Okay. Now I minimize all the tabs. So basically my hands, I can just control the my PC as of now. So I'll just share my PPT. One second.
Nice, yeah. Nice, yeah. Why is
It
there
was
why
just
is there
starting.
echo? There's an echo in my.
There's an echo in your voice. Yes, sir. There's an echo.
Hello. Hello.
Yeah, I can. We can hear you, sir.
No, there's an echo. I don't know why. I don't know why.
There's an echo from my end.
No, no, from my end. No, no, from my end.
Yeah,
Yeah,
there's some
proceed.
noise.
Yeah, proceed.
Yeah. So right now we just saw how just my hand gestures just controlled my whole screen. It could play songs, or it could pause songs. It could increase the volume. It could decrease the volume. Though there was some ups and downs in volume, but the rest of the things it did it smoothly. So what might have done it? Any idea? How could I have just controlled my system with just hand gestures? It looks futuristic at once, but what do you think might be the reason?
Some kind of object detection
Okay,
leading to
we
some
are two types of
hint of what the computer has to do.
correct. Okay. One is the OpenCV. There are rules and there is machine learning happening in the background. So what machine learning was happening here is my hand. So basically, the machine doesn't know what are fingers, what is an hand, how does a human hand look. So I have bought in MediaPipe hand, basically the hand trained model. So I have just imported that and played with some rules. So if I just connect my two index fingers and if I leave it slowly, all the windows will be minimized. And one more rule was if I just show three fingers of mine, basically index, middle, and ring. So it will go to the next song. If I show peace sign, it will go to the back, the previous song. If I show thumbs up, the volume increases. And if I show thumbs down, the volume decreases. So this was all the play. So now, what is machine learning? Everyone talks about machine learning every single day. AI is booming, and AI is taking our jobs. We don't know what ML is. It's too complex. What do you think uh, machine learning is or AI is? And also, there is some example. Uh, if you have Netflix, you can just see once you start scrolling in Netflix, it just gives you recommendations out of nowhere, like similar titles or the titles you used to watch, like wherever your finger touches, and it just reads your calculation. It's at the front end, it looks magic because whatever your intentions are, like I want to watch this movie, or you're feeling to watch something either romantic or horror movies, so Netflix just gives you recommendations after just one or two searches, even at the first starting run of the application itself. Same goes to Swiggy. At the front end, we just see that it will tell you in prediction, like in 9 minutes, you'll be getting your biryani at your house, or in 12 minutes. So how does Swiggy know that exactly in 12 minutes that the delivery partner, or in 20 minutes, like, okay, Swiggy is a food partner. So in 20 minutes, the delivery partner goes from nowhere, he goes to the restaurant, picks up the delivery item, basically your food, and comes to your home in probability, like almost 90% of it will be true, like 19 to 20 minutes. How does Swiggy know it? And even Google Maps, while going, it knows our traffic data. It knows in the middle if there is an accident or construction happening. Even bank. Just imagine I'll wake up at midnight around 1 o'clock, and I'll just send 50,000 or 1 lakh, or I'll do multiple transactions to my friend. Bank will all of a sudden flag me. unsafe. I'll get a message from the bank. Is it you that's actually who is doing the transaction? Because the banks have been seeing my transaction. I'll just be eating pani puri of 20 rupees every day. But why is this guy doing 1 lakh transaction that too at midnight? So the bank just flags my account. So these are all part of ML. It's a day to day, every single day, we are looking at how we are using ML within our own lives. So these were just the few examples of ML. So next is, I'll just, there is some color problem. I'll just share my PDF. Okay, is the PDF visible?
Yes.
Yes, yes.
Okay. So what is AI or what is ML or what is deep learning? So if I ask you all what is AI or what is ML or what is DL, let's talk about DL later. What is AI and ML? If someone asks, let's check I'm the interviewer and I'll ask you what is AI and what is AI and what is ML? What might be your first answer that comes to your head? Anything is fine. It's we have always stick to the textbooks that okay, if I talk just like I mean, if I just give the proper definition from the textbook, my answer will be right. Nothing like that. Just give an example and link with it. If I ask you what is AI, what is ML, what would be your first answer coming to it? Volunteer answers are acceptable.
Okay, so I think I would say that we train
We
machines to
train
behave
machines
in a
to
certain
behave
way.
in a certain way.
Okay, that this would be AI. What would this be? Like, are you talking about AI or ML?
AI.
AI.
Okay, what would be ML then?
It would
It
learn
would
from
learn from
we would provide
we
it
would provide
data
it
set or
data
something like
set
that.
or something like that.
Almost true. So now, what is AI? AI is like, I'll give you just an analogy. Let's take a restaurant. So basically, AI is a restaurant, and ML is like the chef who is cooking as a food. So AI is a restaurant in the sense it's like it's a collective thing of everything. Basically, AI is nothing but which mimics human human stuff like thinking or like whatever human does, AI does. So AI is a collective of these. Now I related ML with a chef. So what ML is, I just give it data. So if I give it more data, it will train on that data. So now I'll just put a chef in the restaurant. So rather than just him feeding, that is traditional programming. The tradition we have difference here. So it's not here. So I'll just tell you there was traditional programming and now there is machine learning. What we did in traditional programming, it was like we used to give rules. So if X, then Y. So in machine learning, it's not that. I give you input, you give me output. So basically, it reads the input of its own and then decides and then gives me the output. Even ML is the same in machine learning. So it's like we give it the data, like the chef. What we do, we give the chef like 10,000 items or culinary food items to look at. So he takes in everything, chews on it, tastes it. Okay, then he'll remember. Okay, if pani puri tasted like that, then okay, that will be pani puri. If dahi puri, okay, there was curd, there was potato chunks. Okay, done. And I'll give him more, like 1,000 to 10,000 food items. That is machine learning. Now, what is deep learning? Deep learning is like, see, I just told that chef is basically ML. I gave chef that some 10,000 food items. But what happens? Even chef has some limits. He or she can't think of every single menu. So deep learning is like these sub chefs, like who can actually help with the chef. Like we have head chef as ML, and we have like mini chefs in the restaurant as DL. So this is AI, this is ML, and this will be deep learning. AI is like a collective thing of everything. machine learning is a subset, basically uh, training the model, like because of your data. And deep learning is nothing but you are just powering up the ML. So this is our main framework of AI, ML, and deep learning. If someone asks, okay, give it an example, you can actually give them this analogy. This is my thinking. So this is AI, ML, and DL. So whenever we start with machine learning, we start with supervised learning, unsupervised learning, reinforcement learning every single time. If we start about machine learning, we talk about this supervised learning, unsupervised learning, reinforcement learning. But what are the supervised learning, unsupervised learning, and reinforcement learning? So I have written here supervised learning, you provide the labels. So it's like I will show you the basically this whole session we have, it is based on supervised learning. I will explain supervised learning slowly. Unsupervised learning is like you don't have labels. It should find pattern on its own. It will find. And there are different clustering, anomaly detection. These are the examples. And in reinforcement learning, it learns by trial and error. What is trial and error? So I have given example as games, robotics, trading. So let me take a game. We used to play Mario before. Like he walks, jumps. Like if while he keeps running, if he just dashes the tortoise or any monster, he just falls. So if he jumps, he can just pass the monster. So in reinforcement learning, it's like reward. So every action has a reward, and every wrong action has a penalty. So now the Mario runs, he jumps onwards. I mean, he jumps like on the monster, so he's just safe. So that's a reward. So if he just goes and dashes the monster, one life is lost. So that's a penalty. This is reinforcement learning. So supervised learning, I will get to it. So the language of ML. So if we talk about AI or ML, and if we actually work on it, people talk about, okay, we need to have data sets, and what is the model, or how much did you train, or how much accuracy does this ML model have. So now what is a data set? So data set is the collection of data. Collection of data. This can be tabular or non-tabular or whatever it is. It can be images in the form of images, or it can be form of anything, unstructured or structured. So here I have given analogy, the pile of fruit on the table. If data set, if I'm talking too much technological raw stuff, don't worry about that. Just think, we have a pile of fruits on the table. Fruits, let's take, we have apple, we have pumpkin, we have apple, watermelon, bananas. So these are all the fruits. So these fruits are data set. Now, machine learning learns with features and labels. So now what are the features? Let's take an apple. I took an apple from the pile of fruits. So now at the first instance, what do you look at the apple? The apple is red and the shape is almost round. It weighs around 100 to 150 grams. These are the features. They are literally features even in machine learning. So just this is the analogy. And the label. So what happens? Okay, I gave you an apple. So if it's just a kid, let's take I have a 5-year-old child, or not a 5-year-old might know, a 1 or 2-year-old child is here, and I'll just give him or her the apple and tell, is it an apple? So the first instance, what the child will tell, if she or if the girl or boy doesn't know what an apple is, obviously it will nod its head like, I don't know what it is. So that's it's not yet trained like what an apple is or what it looks like. The child doesn't know. So same with machine learning. We give it the data, we show its features. So at the end, we need to see if it's predicting it right. If the apple is red, okay, if it's red, round, 150 gram, okay, this might be an apple. That will be the output from machine learning. So the model, the whatever training we are doing with the data sets and whatever features and all we are feeding, that would all combine together with algorithm learning. This is called a model. These are the models that we take in and put up with other AI, so that we get like let's take the gesture example itself. So the model was already trained on millions of hands images. So millions of hands images. So what was that? Hands. Hands was my feature, and my features had fingers and nails and all these knuckle joints. So that was what the trained model. That was the trained model, which I showed in the beginning, the gesture. So the next is training. Okay, now we come to the 1 2 year old child who did not know what an apple is. So now what we'll do, we'll take that 2 year old child, we'll make him or her sit. Okay, or we'll name something. What shall we name the child? Give some random name, any name, so that we can have that reference. Anyone?
Does it have to be male or female?
No, anything is fine.
Okay,
Female, male,
let's go
anything.
with Arun.
Pardon?
Arun.
Tarun.
A.
Arun. ARUN.
Yes.
Okay, let's check Arun. We have a 2 year old child called Arun. So now Arun doesn't know what an apple is or what color. He doesn't even know that the color is red. He is basically a new model. I'm just giving you an analogy, so just we can have an easier explanation. So Arun doesn't know anything. Arun is like a fresh brain. So we'll make Arun sit, and now we'll show him, we'll take an apple and we'll show him. We'll tell him, this is an apple. This is an apple. So he'll be like, okay, apple. Okay, the user is telling apple. So even Arun will try, okay, apple. At first he'll be like, something. Then as slowly, even he will learn, and he will be perfected with the pronunciation. And then we'll tell, apple is red. Okay, what is red now? It's a new feature. Red is a color. So red. Okay, apple red. Apple red. So this is training. Now loss function. Now Arun knows, okay, this shape, the almost round shape with the red color is apple. He knows that's an apple. So now what I'll do, I just confuse him. Rather than an apple, I'll just show him an onion. We know that's an onion, but Arun doesn't know that's an onion because he's not trained. Like he has not seen onion, or he's very rarely seen onions. So what I'll do, I'll just show him onion and tell what it is. So what happens? Arun, he has seen so much apple, so much red. He'll just tell, okay, it's looking almost same. It is round. It is almost red. So it's an apple. So what I'll do, I'll just tell him like, no, it's not an apple, it's an onion. So that's a loss function. It's like showing that what actual problem, like what is the actual thing, what he did was not right. So that is loss function. And we have weights and biases. um, so Arun, when I gave him an apple, he saw the shape and he saw the color and then decided it was an apple. Now, okay, I trained him with 2 apples and onions. So now he knows, okay, onions are too much round. They are pink and um, they have different textures. So now he can distinguish between apples and onions. So now, how does he know that? In ML, we use weights and biases. So with every weight change, the ML model learns a bit differently, even with Arun. So he knew apple is smooth surface and it has a red color and it is round in shape. So okay, he'll know that's an apple. Now if I give him an onion, he will know that there are the texture is different, like it has wavy texture a bit, but it is still round and it has a pink to reddish variation. So the differentiation, how Arun got it, we call the same differentiation as weights and biases in machine learning. So inference. So what I'll do, okay, Arun is very much trained with what is an apple and what is an onion. He knows every single thing. Okay, apple is 150 gram. These are the features. Again, I'm telling you, it's just an analogy. These are the features: the red, the round shape, the gram weight, 150 gram. These are all the features of an apple. So Arun knows it completely. Even about the onion, he knows it's very round. It's pinkish to reddish. It has different textures. It is around 50 grams. He just knows about apple and onion. You ask him anything about apple and onion, he knows everything. But now what I'll do, I will, we will go to the market. Me and Arun will go to the market. So he is so much familiar with apple and onion that if I show him an onion from far away distance, he will tell it's an onion. If I show him an apple from far away distance, he will know it's an apple. What I'll do, I will just change the fruit. Now, me and Arun and me, we are in the market right now. So I will just change the fruit and I'll point to watermelon, or I'll just point him to watermelon. So one of the feature of watermelon is okay, it's round. So what Arun will do? Okay, it's round. Okay, fine. It's apple. I will point him to watermelon, but Arun will show it's apple. So now what the problem was here? An issue of underfitting happened. So basically, Arun has memorized about apple and onion so much that he doesn't know how the outside world looks like. When I took him to the market, so inference is the same. I have trained my model very much that it knows whatever I feed, like whatever during the training I have fed it, it knows it very well. But when I tested the same model in the real world, so it just hallucinates, like it gives random answers, like whatever it was trained on. But the output was something else, but it gave on whatever it was trained. So this is inference. So inference is nothing but I take Arun and show him the outside world. If he will actually tell that's a watermelon, that's an apple, or that's a onion. So that is inference. Basically taking my model and deploying it to the outside world so that I can see how much my answers are right. So next we talked about features and target. Okay, can anyone tell what was features we discussed right now? What was the features we discussed? I don't need textbook explanation, just whatever you understood. So if I know that we are on the same line.
Like for the apple, it was the color and the shape of the apple. So that's how
Right.
you
These were the
can
features.
tell that.
Correct.
Okay.
Right. And what was the target for the apple? What was the target? Give a general example. That's fine. Features, absolutely right. Those were the shape, color, and everything. What was the target?
Target was answering whether it was an apple or not by on the basis of the features which were checked.
Correct. Right. So these are the features and targets. So this is one more example which I'm showing here. So whenever we go to a house, or whenever this is a basic ML foundation. Okay, like every time if you are learning machine learning, we just don't go to the modernized machine learning. We learn it from scratch because these are the things which made ML what we are looking at 2026 right now. So without these, there is no 2026 ML. So these are very important for us. So that's why I'm just covering all this. So we have area, square feet, and bedrooms. So whenever we go to an apartment, we'll go to a dealer. How much BHK is the house, or how much is the overall square foot area of the house. So without knowing that, we'll never know the price. If I take a 1 BHK and the square feet is around 1900 square feet, the price would be around, if I'm buying the house, not renting, if I'm buying the house, it would be around 35 lakhs in some areas, 1 BHK. That's prices have inflated. So if I take 2 BHK and the square foots have increased, the prices increase as well. The target increases. So this is features and targets. So just know, if anyone asks about features and targets, this is the one. Proper textbook definition is: feature is an input variable the model uses to make prediction, like the apple shape, color. Those were the input variable. Target is okay. After knowing all that round, red, 150 grams, it's if it's an actually an apple, so we'll know the output. So features are always determined with a letter X and target with a small letter Y. Training and inference. Okay. Okay, I did tell about inference. Do you people remember what I told about inference? Anyone? That's okay. So training is like we in the machine learning world, first we train the model. There is never a model at the beginning itself. So it's always first the data and the labels we give it, and then the data and labels we mix it with the algorithms, basically train on them with the algorithms. Then after all this, a model comes. This happens during training. The end result of a training is model. And how does a model come again? It's based on the uh, data labels and the algorithms which we train it on. So the end result is model. And in inference, what we do, we take the same model and we provide it with new data. Like I told, I took Arun to the market so that he can know what other fruits are. So I took the trained model, I took the model to the real world, I show it the new data, and I'll tell, okay, you have new data, so let's see how much prediction you do. So that is inference. Training is nothing but you have your data and labels with you. Labels is nothing but whatever, weight, those are all labels. Data are just numerical values or whatever the raw data you get. That is combined with algorithms, and we get a model that is in training and inference. The trained model, when checked on with the outside world, and then it is predicted, that is called inference. Hope you understood of what I'm telling. So in coding terms, we take model.fit and x underscore train and y underscore train. What was x and y again? What is x and what is y here? Why did I take x and y?
X
And y
was
is
feature
okay,
and Y was the target.
correct. So features train and target train, and then we have the model prediction. This we will come to this. I'll show you during the hands-on session. Okay. So, do you have VS Code or Google? Do you have VS Code with you?
Yeah.
Uh, okay, both of you have VS Code with you?
Yes, I have it.
That's all right. Oh, okay. We'll use Google Colab for now. So what I suggest is, stop it. So what I suggest is during the initial phase of model learning. See, in machine learning, we never understand the stuff of machine learning if we don't implement. We will make mistakes. We will make a lot of mistakes, but once we it's like 80% of it should be practical and 20% of should be theory. So once you apply machine learning, and then if you don't get okay what's happening, then you come back to theory. Okay, if I do data augmentation, or if I change the features, or if I add the features, then I will then the model gets a better understanding. So this is how machine learning works. First is practical, then we come to theory. So we'll just 1 second. And also, why did I mention collab specifically? Because initially our laptops don't have so much better GPU that it can train a model. See, basically, if you want to train a model, we want GPU. Without GPU, we can even. I'm not denying that CPU cannot train a model. CPU can train a model, but it is a huge hectic version because that's a complete different thing that we'll have in some other session. But for training any model, if you have a GPU, then much better. Even though if I have a gaming laptop with me right now, all the models I cannot train on time. Google Colab does provide us the free GPUs. Like it's a rate limited, not we cannot be running it 24/7. We have T4 GPU, so it can run any model. Like if you want to train a model from scratch, or if you want to fine tune a model, so it can do that. Like Google Colab, if we start with it. So I'll 1 second. I'll just share. I have the code ready with me. We can do either of the things. Either we can I'll just explain you the code, or you can actually type in. The first session, I mean, the first learning, I would
Sanket,
actually want to.
Sanket, let Aksa type the code. You keep
Okay.
one by one line. You send it on chat. Okay.
Shall I send it on chat, or will I just share the screen?
No, no. Send by chat.
Send by chat. Done.
Line by line. Let her because she has some knowledge of Python. Okay.
Okay.
Even though we
Got it.
may not be able to complete it, let her type line by line. It might help. Okay.
Okay. Fine. Fine.
Yeah.
Okay, before I start sending, do you know about pandas and numpy? Any one of you? Everywhere we have word pandas, numpy, matplotlib, even matplotlib. What does these pandas, numpy, matplotlib mean? Even anyone, any idea?
As of now, we had it in Python. NumPy is used for as a third party so that we can use arrays, multidimensional arrays in Python.
Correct. Okay. And what about pandas? Arrays is completely true. I won't repeat it again because whatever the definition you told, it's a Python library, and whatever the definition you told was exactly true. And what about pandas? Any idea?
I've not heard about it. Like we
Pandas.
have heard about it, but we don't know what it is.
Okay, so NumPy, whatever she told, that's correct. Basically, it converts to arrays, right? Pandas, what happens? We do data manipulation with pandas. So, if I want to give an example, let's take for creating the tables or for cleaning, Panda library is very much important. So even though in 2026 we just jump on, we do Cloud Code or ChatGPT, anything, but these are all the small things which give us the understanding of the tables what we see, and the graphs what we see. And pandas is just for data manipulation. And what about matplotlib? Any idea? Matplotlib is used for like whatever graph you see, the confusion matrix, or all these linear regression, like the linear models, or the heat map. These all this comes under Matplotlib. These Python libraries are very important. Pandas, NumPy, and Matplotlib. So okay, for now we know about features, we know about labels, so we know what features and labels are, and we even know what data set is, and we know what x and what does y mean. So now let's start with hands-on. Like I said, we if more practical is done, then it's well and good. Um, as Sir told, you already have a knowledge of Python. So we'll be doing linear regression for now. Oh, please open your Google Colab. Hope the Google Colab is ready. Please open Google Colab if not. If yes, I would want to see a reaction or an S from anyone. Okay. Open Google Colab and open a new notebook. If anyone has any confusion on opening notebooks, please do tell me. I'll just show you how to open a notebook. A new notebook. Has everyone logged into Colab? Okay. What about Mariam? Because before I start, I'll just we have less time. If we had a longer session, if we had a face-to-face session, it would have been much faster. Okay. Both have you opened. So what I want you to do, in one more tab, please open Kaggle because this takes a long time. So we'll just finish the starting stuff. Open Kaggle and just sign in with your account. Sign in with Google for Kaggle. If it's already signed in, please do let me know.
Yes, I've signed it.
Okay, both of you.
Just a minute. Yeah, I see.
Okay. So can you see my screen?
Yes.
Okay, I have opened Kaggle. Now what I want you to do is here, one, you have your username here. Or whatever. Mine here is Sanketh with caps H. What I want you to do, this is our username. Here, go to Google Colab, open Google Colab tab, and you have something called like there's a symbol of key here. If did you get it?
Yeah.
Yeah, just click on it and add new secret or whatever it is. Uh, for the first thing, add this one. It should be the name should be the caps Kaggle underscore username. Let it be in caps. Everything. The name should be Kaggle underscore username. I'll tell you why we are doing this. It should be in caps. Kaggle underscore user name. If it's done, go to value and you have the username here.
We should add our usernames, right?
Yes, your username, right? You'll get your username by clicking on this. I have a duck here on the right corner, top right corner. If you click on that round icon, you'll get your username here. Mine is SankethHegde. You might have different usernames. Just inside value, let your usernames be as is, like here. SankethHegde. I can just copy paste it. So no problem. Is it done? The name will be Kaggle underscore username. The value will be your actual username from Kaggle.
Actually, my username has space in it. So can I use underscores instead of
No, what you do, just
space in the name?
select the whole text, copy it, and just paste it inside under value. If
Value
you
I
get an
have
error later
enabled
on,
the same.
huh?
Just I'm asking about the name.
The name. I'm just select the whole text, whatever the username is there. Just whatever there is, just keep it in under value. We can just even just copy paste it. Why I'm doing this, because Google Colab, like I said earlier, you might be using Google Colab more if you want to train a model or if you want to understand what a model, even if for college projects or any other projects or mini projects or whatever you want to do, or even if you want to deploy something in GitHub, and if you want to fine tune a model or make a model of your own, you will be using Colab more than VS Code, because in VS Code we cannot be training a model because VS Code will just take whatever GPU we have in our systems. If you have a very good GPU, that's totally fine. You can use that. But if you have no GPU or very low end GPU, I would suggest to use Google Cloud. Why I'm using Kaggle username, because we will be using data sets from Kaggle mostly. Most of the time, not every time, but most of the time we'll be using data sets from there, because that's our whole, it's like literally a library for data sets. So adding these keys will make sure that anytime if you want something from Kaggle, you can just type in that URL, and all the data sets, it will be unzipped and it will be opened, rather than you going to their data set, downloading it in there, and then uploading it in Google Cloud and then unzipping it here. That's a very huge issue. These are all small things which will make our life easier. So that's why I just told this. So if Kaggle username is done, next should be Kaggle underscore key. It should be in caps. Once you know Kaggle underscore key, hope it's done.
Yeah.
Okay. We'll go to the same, the duck icon I have, the round icon in my profile. Here you have your API tokens. In the sidebar, you have your API tokens. Just click on it. And next, you have something called generate a new token. Hope everyone has it.
Yes.
Click on generate a new token. Name something, whatever you want. Just type machine learning if you want. Anything is fine. No problem if you have weird token names also. That's fine. Give any token name, generate, and you will get an API token here. Once you click on generate there, after you give a token name, just click on this copy to clipboard. It will be copied, and now it will be copied. Don't worry. And next, go to collab, and then click on value. Just paste whatever the key was here. Is it done?
Yes.
Yes.
Fine. So let's start with the basic machine learning. So this is where we actually, this is one of the many classifications. Uh, this is called linear regression, which I'll be sharing the code with you right now. Give me a second. Okay. I'll just share it in the chat. You can just name your collab notebook as linear regression or whatever you want. Initially, we'll be calling the Python libraries like we discussed earlier. First, we'll be adding the libraries, pandas, numpy, and matplotlib. Hope you know what we discussed. And the next we'll be working on sleep prediction. So we are already set into learning about ML. So sleep prediction basically, let's take. I slept at 12 or 11 p.m. tonight, and I wake up at around 4 a.m. tomorrow morning. So that is almost 12, 1, 2, 3, 4, 5 hours of sleep. So we are dealing with hours slept and alertness. If I just had 5 hours of sleep, I might have a alertness score of around 6. So if I had 8 hours of sleep, I might have an alertness score. Alertness in the sense, the next day if you wake up, you won't be like all woogie woogie, whatever it is. So alertness score is the higher the number, means the more hours you have slept. Like basically you're fresh. If the alertness score is less, uh, then you have slept for less hours. I'll just share you the. Here df is nothing but data frame. Um, So, like I said earlier, hours slept is basically 3 hours, 4 hours, 4.5 hours, 5 hours, 5.5 hours, 6 hours, 6.5 hours. Alertness is basically alertness score. So, for 3 hours, alertness score is 2. For 4 hours, it's 2.5. For 5 hours, it's 3. So, hope you have put it in one cell and you can run it now. Okay, you can run it now. Just it will connect. Please do let me know once the cell has run. Basically, what you'll get after the cell, that you have given a linear set of data. Basically, you have given 3, 4.5, 5, 5.5, and for alertness, you have given 2, 2.5, 3, 3.5. Once you run this cell, it will give you a tabular structured way of these data. Just let me know once this is
Yeah, I got it.
okay. What about who spoke now? Was it Masiha or Maria?
Yes.
Okay, fine. I hope both of you got that data set. Basically, this is just a data set which we created. We have data sets in Kaggle. Like we did not take any data set from Kaggle. This was our data set. And even if you want to change, this was my data set. If you want to change the hours, you can actually change the hours. If you don't want 3, 4, 4.5 as hours, you can just add 5, 6. Basically, make your own data set. It need not to be the same data set as ours. So basically, we are creating the data set for now. You can just change it if you want. Next is df.describe. Run it in the next cell. Like, run it in the next cell. If you are new to collab, have both of you worked in collab? No, okay, fine. One second, one second. Okay, in collab, if I want to add a new code, like you got the data set like this. Like I said, you can just change the data set here. I just change it to 4 hours, and alertness would be increasing basically. 2.5, let's check it. 2.5. So just run it. So I got an updated data set here. If I want to add a new cell, just scroll it here and you'll get a code here, like it is fast, or you can just click here plus code, or you can just browse here. Take your cursor here and just add code here.
Okay.
Okay, so next is df.describe. Now what df.describe does is, so basically I given you a data set. It will just give the basic understanding of machine learning is basically playing with these variables like count, mean, and standard deviation, minimum, 25%, 50%, 75%. What is 25%, 50%, 75%? And actually, what do you think? Like, did you guys run the cell df.describe? What might it be?
Yeah, it got count, mean, STD, mean
Right.
25%.
What? How did it come with these numbers? If I mean, where did these numbers come from? Under describe. So basically, it's nothing but max is 9. So when you look at, just go up, scroll up, and if you look at your data set, the last number, the highest number, what we got is 9. So here max is 9. And when you calculate everything, and when you take an average of 75%, you'll get 7.6. And if you take it as 50%, like it does its own calculation. That's the beauty of machine learning. We'll be having mathematical equations running in the background. We'll have in-depth of machine learning some other time. So this is the basically it's just describing our data set. Like we can just manipulate with these data later on. So next is run this in a new cell. Did you get a plot? Or was there any error?
Yeah, I got a graph, kind of.
Okay, what about Masiha? Am I pronouncing it right? Masiha, right?
Yes. I also got a note.
Okay. So it's nothing but look at the code. We dealt with x and y. So here we are not taking the x features, y output. No, here is just the plot. X is hour slept and y is alertness, and these are the plot sizes 8 and 5. And we have given the labels. So x label, the x coordinate label is label is hours of sleep. Y coordinate label is alertness score, which is exact as it is. So it's just showing how our data. So basically, whatever data we gave at the first is just describing. Okay, this is how the data looks like in a scatter plot. Next, now we'll come to features and target. Basically, the x and y. This, please run it in the next cell. I've added the comment as well. Features is input, like what we discussed. Arun, like we showed him apple round features, and the Y was the target. Was it an apple or not? That is what we wanted to know.
I got it.
Okay, done. So, okay, next. Okay. Now, what we'll do next is train tests level split. 1 second. Just screen my share. This is just a starting thing, so that if you know this, we can have complex ML models learning much more pretty easier. So these are just basic things. If you know, you can actually. I understand. Even I use Claude or I use ChatGPT a lot. But what happens? Majority of the people don't read the code. So basically, if Claude hallucinates, basically it gives some random code, and it breaks the code. It might be just with some it breaks the code because of one single line. We will think, okay, the whole code is broken. We should make an habit of reading the code at least, so that we can know where the AI has gone wrong. So whenever AI makes mistake, we'll tell it to repair the code, debug the code. It will keep on breaking more code as we go, because it doesn't have proper knowledge. So these are the small stuff. If we know it better, we can actually train ML properly. I'll just share the screen once again. Okay. Till now, we have done. You have got your data set for what is it, sleep and alertness score, and you have described like how your data set looks. And with calculations, you have got certain values, and then you have got even a plot of x and y coordinates. That's all done. So now we have data sets. How many data sets? Like how much values have you got? If anyone can count. Total, how many values are there? I mean, not combining both of it, just one. Let's take a predict this one, the alertness score. Okay, let's take alertness score. How many values are there in total under alertness score? You can just check it in the table which you made it in the second cell. Yeah. So here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we have 12. So basically, we have 12, 12 numbers. So right now, it's just a numerical data. So we have 12 numerical data. This is how I counted: 2.5, 2.53, 3.54, 4.55. There are a total of 12. So now train test split. So what happens? We cannot be like we took the analogy of Arun. So what I did, I trained him with apple, and I trained him with onion. But when I took him to the market and showed him a different variety, he couldn't analyze it. So what my problem was, I just trained him. I did not test him. So what we'll do here, we have 12 numerical data. So in that data itself, we'll take 9. Yeah, if we take 80%. So 9 will be for training set and the 3 datas will be for test set. 9, it will take random. Random 9 numerical data will be for training set and random 3 will be for test set. So basically when the model is trained on those 9 numerical data, I will give so that I'll make it test on these 3 data, 3 numerical data. Hope you guys understood. Can I know what I was talking about? Because this is very important. Like if I want to fine tune a model or if I want to create my own model, this is very much important. So can anyone explain? Like just give me a brief. Like what is a train test split? It doesn't have to be exact proper textbook definition. Like whatever you understood or did not. If you did not understand, please do let me know. I'll just give you a different analogy for that.
Yes, can you please give the
Okay,
different
fine.
analogy?
So train test split. You have your own data set. Let's take. I'll give a random example. Uh, you can look at my face right now. So right now, this is my face, and I will give a model. Basically, I'll create a data set first. I'll create a data set of my face. So what that data set is, I'll have around 10,000 images of myself. I know I'm self-obsessed. So 10,000 images of myself having different emotions. So around 2,000 images will be me smiling. It won't be just like this. I'll be like showing my teeth or light of smile. 2,000 images of light smile and 2,000 images of me being just sad, like just very my eyebrows are raised and my lips just like you see just sad posture. And one more is crying. So basically, I'll have tears in my eyes. So all my eyes are all tiny. So another 2,000 set of images. And then one more is any other emotions humans have got? Too many emotions. Any random
Angry.
emotions? Just give me an example. Huh? Which one? I
Angry.
did not hear you. Angry, right? Angry. Okay. 2,000 images of angry. Me having my eyebrows in this like literal anger posture. 2,000 images of anger. And one more? Anything? Happy, cry, sad, angry, and any other emotion which can be visually seen.
Straight face.
Snake face,
No, straight face, like no
straight face,
emotions. Yeah.
straight face. Okay, neutral. Okay, fine, neutral, neutral. So it's just like this 2,000 images. So people looking at dataset will be like, how could you have even so much patience to do that? So 2,000 images of this. So now what do I do? Now I have created a data set of my own. I have clicked 10,000 images of mine with whatever you gave me idea of happy, anger, sad, crying, or what was that? Another or one more, whatever, a straight face, neutral. So what I'll do with this is a mixed. So basically, inside the data set, I will have all these images, basically labeled images that happy, 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 sad, 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 whatever it is. So now, what does train test split do is the data set of mine. I'll just tell the ML model. It's not a model. Basically, I will tell the Python to differentiate my data set of 10,000 images with of different emotions. I'll tell you to randomly differentiate. Uh, Pardon? Am I audible?
Yes.
Okay. I'll tell you to randomly differentiate. It's not like you should take first 10 images only or first 50 images only. Actually, it's a good practice if we do it orderly wise because even the model doesn't know what all it is. So that's okay. Anyhow, so 2000 images of happy in the sense I'll take around 1500 images for 1080% of how much is 2000, how much is 80% of 2000? Any idea? 1600. 2000 1600. Okay. So I'll take 1600 images of me being happy. I'll leave the 400 images separately. I'll just keep the 400 images side. I take the 1600 images of me being happy and I'll feed it to ML model. I'll take 1600 images of me being sad. I'll give it to ML model. I'll keep the four. I'm not giving 400 of those images to my model. It it doesn't even know those 400 exist. I mean, initially, while for Python, I will just we'll figure it out. I'll just show you. Those 400 images are separate content. The machine learning model will never train on those 400 images. And 1600 images of me being angry, I will train. I'll give it to the model so that the model can train. I'll keep the 400 images side. So it's basically a split of my own data set. So 80% of my data set images will go for training, 20% for training, because so that I can understand, okay, it has trained so well. Let's see if I can give this out of randomly. Like I'll just tell it that, okay, see, these are the new pictures I've given. So let me see if you can predict. So I'll show you. One second. Just check the chat. The next is train test split. Paste this in a new cell and run it. Yeah, tell me once it's run. And also, is it done?
Yes, it's done.
Okay.
Yes.
It's mentioned training samples is 9. It tells model sees these. Test samples are 3. Model never sees these until evaluation. Did you understand what is a train test? Like whatever I told? No. And
Yes.
all. Okay, fine. So how did it get to know that I should take 9 and it should take 3 for test? Any idea? Like look at the code.
It was like 80% and
Ah, that's right. That when we spoke, that is correct. But how did the machine get to know that I should take 80%? Like how 9 is given for test and 3 is, sorry, 9 is given for training, 3 is given for test. Where in the code I have mentioned that 80 and 20% is split? If you see the code, the second line, X, basically X, the capital X is features, Y is label. Test size, test underscore size is equal to 0.2. So basically 0.2 is nothing but 20%. And 0.8 it has taken, if it's 0.2, the whole one, the rest is 0.8. So it has taken the training size as 0.8 because I have already mentioned train underscore test underscore split. So it understands, okay, he's trying to split the data into training and testing. So now how does he want to split the data? He wants 20%. And also I can even increase the size here. So if I make it test underscore size is equal to 0.3, it will take 30% for testing the data and 70% for training. This is how it works. Okay. Next. Okay. Run the code in the new cell. So from SQL linear model, we are doing linear regression. Import linear regression. So what is importing? Linear regression is nothing but the algorithm. Import linear regression algorithm. So the model is linear regression, and for any training you have to do, that is the basic thing. Model dot fit x underscore train comma y underscore train. That's a universal thing. Even if you are gonna train a very huge model which runs ChatGPT or Claude, this one line is very much important for any training purpose. And then we have weights and biases. So like I said earlier, there was a mention of that in the slide as well. So weights and biases. So if I tell the apple, Arun has an apple, like me showcasing an apple to Arun. If I just change the apple color to a bit red to green, or let's change the weight of the apple. Even if it's 130 gram, it's an apple. Even if it's 100 gram, it would be an apple if everything else matches. So changing with weights and biases. This is weights and biases. Next is loss function. Loss function, like I said, when Arun was trying to figure out what an apple was, he before he learned what an onion is, he was just focused on apple. So when I showed him an onion, he told something. He told even that was an apple. So what I did, I just gave him a tap on his hand. I said, no, it's wrong. So that's what loss function does. So it's basically like it shows how much wrong the model is predicting. That's the function of loss function. Next, please add this in the new cell. So now we have a generalized linear regression. So um, gray lines. So here it's given as gray lines is equal to loss minus training minimizes these. So linear regression is nothing but a straight line, linear regression. So here we have linear regression, and you can see the blue dots. The blue dots are nothing but the data which we had given at the start. That is our data, whatever the data we fed, like typed it and fed. That's it's training on that data. So there's a gray line like dot 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 for in the blue dots, like between the line and the blue dot. So that's nothing but if we do this, then that like we know that there is this much loss. So the more the training we do, the much less the loss we get. So this is what the graph shows. And next, finally, we come to this. Run it in the new cell. This is, you have already trained the model now. Basically, where did you train the model exactly? You gave it, you trained it with loss function, and you give it the weights and biases. Like I said, like I mentioned earlier, that this one line will even make like that's very much necessary for ChatGPT or even Claude to learn their models. The training model, model dot fit x underscore train y underscore train. That's where your model trained after you ran that cell. You couldn't see that, but you have seen that in the cell. The training done. Weight, it has given 1.24. These are all. If you scroll up, check the cell where it is mentioned as training done. So the weight and bias it has given. So did you run the cell of this?
Yes.
Yes.
Okay, what do you understand with this? Like you can actually slide hovers and can you slide it?
Yes.
Yeah.
So as soon as the hovers increases, how much like don't you get what like give me examples? Let me see. What are you getting when you ran the hours? Like increase or decrease the hours?
Like when it is less, it shows very drowsy. This is who we are detecting next. And when it is
Right.
full, it shows that alert. And in
Right.
between, when
So
it is
what is it? Basically, so hours is showing how much when it is full in the sense hours is
hours is 10,
hours is 10 and it is showing
10 XL alert.
that's correct. What about the naming output? What is the prediction given?
It says alert.
It says alert because 10 you have slept for 10 hours. So if you have slept for 6 hours, it would be like below average. So machine other than coding or we never give it law rules that okay if it's more than 6 hours show it as below average. We have never, you can check the code again, we have not done this. So this is basics of machine learning. So this is literally machine learned whatever we want. So but the main thing was we gave it data. So based on the data it's giving me output. So if I slide it for 8 hours, it shows me alert. Or if I slide it for 3 hours, basically if I just slept for 3 hours, so obviously I'll be very drowsy. So this is how prediction actually works. This is basic machine learning. So I'll just screen share. We are done with this. This is linear regression. One of the popular. Whenever we want to learn machine learning, we start with linear regression because that's how machine learning grows. Share my screen. I don't know if it's boring or not interesting or interesting. I don't know.
Really
I'll,
cool.
I'll ask you then. Okay. When I was talking about Arun, I don't know if you will notice that I mentioned underfitting. So what underfitting means? Underfitting is nothing. These are all very popular terms in machine learning. Without this, we, we if you understand this, we can actually then apply while during the coding session. So underfitting is nothing but it has just trained on whatever data you have provided. So basically, if I give it outside data, basically Arun did the same when I took him to the market. I just knew he just knew apple and onion. When I took him to the market, he did not know what the other fruits were. That is underfitting. And then good fit. Good fit is like basically generalized. Uh, even if I took Arun to the market and if I show him watermelon, he will understand. Even if it's round, it's very huge. It's more weight, so it's uh, like he looks at the features and then he predicts. Okay, this is a watermelon, and and overfitting is it basically memorizes on training data, and it includes noise. Well, I'll show it to you. A loss function, I'll show it to you in the next steps. Okay, optimizer. Optimizer is nothing but, okay, like I said, loss function. During loss function, oh no, what, Arun, we were given apple and onion. He just, okay, when he was just learning apple, when I introduced him to onion, he even thought onion was an apple. So I tapped him. So that was loss function. Basically, I was telling, no, it is wrong. I just told it is wrong. I did not correct him. What optimizer does? Optimizer actually, it's like a parent who makes you learn. No, Arun, this is not an apple. This is an onion, and it teaches it's an onion. It's an onion. So that's what optimizer does. Loss function just tells you're wrong, and why are you wrong? Like it just shows okay you're wrong. Optimizer it makes it learn like a parent, like how our parents make us teach proper. Okay, if I make a wrong thing, they will just tell me, okay, this is wrong. this is onion, this is onion. So you hope you understood what I told. And the most common optimizers we use are Adam. Uh, in current trend, we use Adam optimizer because it's more efficient. Okay. Accuracy loss function. Hope you know what loss function is. Accuracy is nothing but out of the given validation. So basically, on test data, it has trained so much on test data that I'll check on. It has trained so much on training data that I'll test it actually. Then let's see. So how I measure how much accurate is that is because of accuracy. So how it performs during using my test data, I can read it through accuracy. Okay. I wanted to show even the other prediction, basically housing prediction. Even housing prediction is very much popular. Housing prediction, California is very much popular in too many colleges or whenever people want to learn. But mine was the Bangalore edition housing. I'll just show you the code. We'll just go on top on top. So basically, I told to add your Kaggle username for this. So if you just do this, if you add this code, you can just we'll just do it. Open a new cell. Open a new cell, or you can open a new notebook as well. That's anything is fine. You can just file, open your notebook, or you can just continue. I just wanted to show how this works. So having Kaggle API is much better than you downloading data sets from Kaggle and then importing it in Google Colab. So if you just add this and run this cell, it will initially show Kaggle ready. And next, if you add this, basically after adding this in the new cell, it calls the data set from the Kaggle platform and then runs it here in your Google Colab without you doing all the downloading stuff. It will just automatically do it. So this might help you in the future if you are actually trying to uh, download data sets, like I mean within Colab, or you are fine tuning a model. So next, same basic, we'll be using Python libraries so that we understand. So the house pricing prediction of Bangalore areas. So pd.read, basically it just pd.read underscore CSVs. I have a huge amount of rows and columns in CSV. So it just shows me what are all the columns we have. I have area type, availability, location, size, society, total square feet, bathrooms, balcony, and price. Your price is mentioned as 39.07. It's mentioned in lakhs. So here 120 lakh is nothing but 1.2 crores. And we have ready to move, and we have locations: Electronic City, Kotanur, Utralli, and we have size. Basically, if I want to see a house, people will talk in BHKs: 2 BHK, 3 BHK, 4 BHK. Society is not required. So what happens if you are actually predicting, if you are actually predicting on a good model, like all these values do matter. But for simple prediction, you don't need all this society or availability. Or no, availability is required. That's fine. Area type is not required, and balcony is not required. Balcony, very posh areas, balconies might be required. Oh, let's take balcony. So what I'll do, I'll just uh, I'll tell Python to remove area type. I'll tell Python to remove availability. Location is very important. Size is very important. Square feet is important. Bathroom is important. And I'll add price. With price is basically my Y. What was Y? It was the output. And X was the features. And these are the features: availability, location, size, society. Price is the Y. So I'll just Python to split it, like give me just locations and size. I'll just do the classification here, data classification. and finally it will just show me these location size, total square foot, bath, price, and BHKs. So here I just wanted to see the graph, how much is it. So for Hebbard, an average price would be 1.2 crores, like we saw earlier here. Where was it? 120 lakhs. Yeah, here 120 lakhs. So basically 1.2 crores. What it did, it took the average of a huge data set. Basically, the data set is here. It just showed me a hands-on of a small chunk of the huge data set. So based on the huge data set, it just gave me a classification of the areas, and then again features and targets. I gave it like we did in linear regression. The same thing we are doing it house prediction as well, and I trained it again here. The test. Hope you can see my screen. What we
Excuse
did
me.
in linear regression. Okay, thank you. What we did in linear regression, we are doing same for the housing prediction as well. So I train, test, split. We did the same thing here. So basically 80% of the whole data set is for training and 20% is given for tests. Next, as with the data, so I start with training. I won't test the test. I'll just start with the training. So I'll use my model for training. So I'll get these values. And these are the weights and biases after training. This is the classification, and these are the loss functions. Like during the training, how much, like during the prediction, like what was the loss and what was the variations, and this is my final output here. So basically, we took only these cities.
I'm sorry to
Uh,
interrupt, but
yeah,
the code that you sent in the chat, it didn't like I didn't get an output to that.
you didn't get the output. What did you get any error?
Yeah, even I got the error.
Oh, okay,
The
okay.
secret
I forgot to mention one thing. Here in keys, did you enable this notebook access? Go to
no.
keys here. Okay, please enable this. I'm sorry, I forgot to mention this. Please enable this and then run again. Notebook access should be open. There is some glitch I feel. When I try to toggle this on, it did not toggle. So I just add new circuit and then I just toggled it on. Then it was on, and then you can just close it once both are toggled on. Is it done? Is it coming?
No, still it shows secret not found error.
Secret keys. Okay, secret which secret error is it mentioning?
It shows Kaggle username does not exist.
Okay. What you do? Go to the secret keys again and open your tab of Kaggle. Your just copy. I mean, um,
She has put her full name in that, and there's space between the names.
okay. Check it out. Um. Okay, maybe try with the underscore. What about who got this error? Was it Mariam or Siha?
Yeah, it's Mariam. I got the error.
Mariam. What about Masiha?
I have a different thing, like it's asking something like replace Bangalore house data dot CSV. I have a yes, no, all, and option.
Yes, yours is working perfectly. Just type yes. Like go to that area, blank area. You'll get a box. Type in
Yeah.
yes. Or
Okay.
it will work. Okay. For Mariam, um, okay, try with underscore like you said earlier.
Yeah,
inside
in
the
the
keys.
user in the name, I had written as it doesn't allow us to write the space. So I
Add you.
used instead I used users underscores.
Okay. Got it.
Now
It's working
it's
now.
no.
What was the error again? Like,
Is it fine if I share the screen so that you can see the
sure, sure,
error?
sure. Please share, please share. Let me. Okay. Canon data set, license, replace value. Uh, okay, it's working from now. How did you get this? Sacred Kaggle user does not exist. That's fine, I guess. Okay. What you do? Just close the release notes. Okay. It's fine if you don't have username, I believe. Um, let's see. You have one more cell open, right? No. Oh, no, no, no. Actually, you might need Kaggle username. Okay.
Shall I
Okay.
copy
For now.
the code once again and copy the
Okay. Fine. Maybe delete that cell if you can. Right. Even this. Can you show me the secret key? Possible. Um, Toggle on the I button. Yeah. Yeah. The I option. The I need to see what's no no. Beside value. Yeah. Okay. Key is fine. Did you do shift enter or something? Like why is the name
no
up and
no
down? Huh.
no I didn't do.
Okay. Try
I'll write
typing
it
it
once
again.
again.
Sure.
So tell me, Sanket, what are you trying to do?
We are just setting up Kaggle so that Mariam can literally pull the data from Kaggle rather than just downloading the whole data set of GBs.
Oh, how do you do that actually?
So it's like uh, if you have API and username of Kaggle, that's
Okay.
more than enough.
Oh,
So whatever Mariam is doing right now, you have your tokens correct, I believe. Uh, API key you have directly copy pasted it, right, Mariam?
Yeah, I had done it.
Okay. Okay. You just let me see the username again. So I want to see you type.
Okay.
Did you type it right now? Did you type it right now?
Yeah, this one I typed it right now.
Okay.
Again, it came.
Again, it came the same. Okay, that's fine. Mariam, can you scroll up?
It comes in
Can
next
you
line.
show me the username? I mean, can you please open Kaggle? Kaggle.
Okay.
What? Did you see the difference? You have given your username as Mariam Aksa Rafiq. Why was
Yeah.
there was some small letter or something? Can I open the collab?
Actually, the an M of the Mariam last M, it went down. I had
Uh,
written it proper,
uh,
but it went down.
okay, that's
I'll
fine.
write it once.
Show me the name.
Yeah. Again, Mariam.
Okay,
Yeah, I
that's
think
fine.
the name is
It's
her
fine.
name again, like Kaggle Mariam Aksas.
Oh, right. The name. Under name, it should be just Kaggle underscore username.
Okay. I can't remove it.
Huh.
Mhm.
Just delete that section if you
Whole
can't remove
thing.
it. Add new section.
It should be Kaggle
Caps, all
underscore.
caps.
Underscore. Should I write
Username.
username itself?
Username. Yeah, under value, now give your proper
Yeah.
whatever, Mariam. No,
I
no,
should
not this.
generate new logo.
No, no, not this. Open the duck, yeah, your name, Mariam Aksa Rafiq. Type the whole proper with
Okay.
whatever you typed earlier, type the same.
Okay. Yeah.
Okay.
Now I'll do this.
Okay. The first, is it working?
Should I do grant taxes?
Grant accesses. Grant access.
No, not again.
Same error.
No, now it's timeout exception.
Is the runtime running?
Uh, it's stopped, I guess.
This part. This part basically it should be green. Is it green? Yeah. Does it show you
Which
RAM?
one?
Does it show this one? This part. The connecting where I'm
It's
getting
here,
connected
yeah.
here. It should.
It's tick mark and RAM and disk.
Okay. You got timeout exception.
Yeah.
Did you grant
Now it
access?
got ready. Now I got it.
Okay. Paste in the next set I sent in the text.
Okay.
So when you do that, you'll get an yes no listing. Did you get that?
No, it's running.
Okay.
Is this the one? Why? Yes, no, on none.
Right. Yeah. Do Y.
So I should. Okay.
Do Y. Yes. So what it does is basically it will just. What about Masi? Did you get it? Did you get the data set?
I did not get the data set.
You did not get it.
I got the link. That's it.
Okay.
Yeah.
Uh,
Like the data set URL.
you got the data set URL. Okay. Then that means it has imported. Okay. If you want to check, just add this in the new cell. Oh, sorry, not. I just copied the same.
Wait, ಬಂದಿಲ್ಲ.
You want to just add this. So if it works, let me know, both of you. I'll just share the Google Colab notebook to Sir later on, so that you can actually understand whatever we went through the process of understanding.
Yes, it works.
Okay, got it. Fine. So Kaggle API is running, and So maybe if it was 100 MB or 1 GB, so it has unzipped and it has just given you through Google Drive without using your storage. Okay, so this was a general example. And what about Mariam? Did you get it?
Getting this.
Okay. Did you press yes there? Why did you
Yeah,
click? I mean,
yeah,
did
yeah,
you
I had done it.
do why? There?
I'll do it once again.
Yeah, do it. Yeah, now it's done. Now scroll down. Yeah,
Okay,
you
yeah.
got the data set.
Yes, yeah, thank you.
So this is basically like a data set on Bangalore area. So after all that, after all the classification of data we got here, I just needed few cities which I was interested in. So let's take Whitefield in Bangalore. So square feet is basically 2,400 is very posh. We'll just take Bangalore around 2,000. Let's take 2,000 square feet. And I went to a dealer and I asked him, so 3 BHK house, how much would it cost? And how many bathrooms? Okay, 3 BHK, 3 bedrooms, so we'll have 3 bathrooms. So, based on my data, it predicted everything and it gave me an estimation of 155 lakhs, that is 1.55 crores, based on the location. So, if I go to Yelahanka, Yelahanka is also cost now. We'll go to Electronic City. Electronic City. Uh, oh, okay. I need to run everything. One second. One second. Okay. What is plan? Okay. Okay. So Electronic City we came. So I adjusted my square feet to 2,000. You can see that it's however I drag the slider, it's getting adjusted. So basically here we do not give rules again. Based on my data set, it's giving me a total prediction of how much uh, based on my BHK, based on square feet I want, how much the price might be actually. So I wanted 3 BHK and 3 bathrooms in Electronic City with 2,000 square feet. Predicted prices in Electronic City is 1.2 crores. So if I have 1,100 square feet, which is very less, and 1 BHK and 2 bathrooms, so it's like 50 lakhs. Very honest pricing. Electronic City, outskirts of Electronic City might be this pricing for now. Not every house is so less, but it's almost it's basically a prediction. So we learned basic linear regression, and now we actually
So
implemented cities.
this data set was from where? Kaggle, is it?
This was from Kaggle itself, sir. Kaggle, yes. I'll show you the data set as well. What was the link here? If we click this link, it will just take me to the data set. Bangalore house price prediction. So 468 people have liked this.
How many rows
So
were
it will
there?
just show.
How many rows were there?
How many rows? Are there? Rows. I need to check. I need to check in the Python code itself. One second.
Okay. Now there's one dimension here which I thought is important.
Okay.
Now this is the price in 2026, right?
This data set was published on.
So is there a year?
Actually, it's an 8 years. Actually, it's not an updated price.
Ah,
Basically, this data set was 8 years ago. So it has
correct. If
taken
there was
data from 8 years.
a year column, then it would have been even more challenging, right?
Right.
Hmm.
True. True. If it was
Yeah.
year column, maybe
We could have
would have been.
added an inflation adjusted, you know. computation.
We can do that. We can still do that.
Hmm.
If the columns, if the rows have it, if the columns has it, we can easily do it still.
Okay.
But there are just 9 columns here: society, total square feet, bath, balcony, price, and area type, availability, location. So based on that particular data set, we classified that data
So
and
I'll give you a small
we
project maybe to all of you. Imagine we have about uh, 1,000 real estate agents in Bangalore, okay, or brokers, what you call. If you can give them a web-based front end for them to add, for every property, they just enter into a web-based thing, 5 6 columns, okay, and that will become a that will generate a continuous data set which will go into Kaggle, and it will be useful for everybody in future, right?
that can be done.
Can be done means now we need a web-based interface to collect data and using the Kaggle API to update it real time into Kaggle. Okay.
We can.
Now you extracted from Kaggle, but here
Kaggle, right?
to update the Kaggle data, right?
This can be done, sir. This can be done. Even it's like you can actually update it in Kaggle itself, or you can just have it stored it in somewhere, like have a database ready for that. So whenever you or me or you update in the website, it will all get collected in the database, whatever the database, either SQL or
Hmm.
any database we have stored. So once the database is kept on collecting, we can just post it in Kaggle.
Right, right. Okay, good.
This can be done.
Yeah, thanks. Yeah, you can
So
complete. We have
also,
another 5 minutes to go.
actually, actually, I this was just with data set. So what happens? I have very less time. 1 second. Okay, hope you can see my screen. Okay,
Yes.
we just went through one word of ML, which was data, numerical data. We just messed it up with the different. We messed it up with cities. Initially, at first, it was just. Did you notice something? The first project, I mean, the first thing we did with was linear regression. It just had one feature, basically, which was the feature which we did the first time. What was the feature? The linear regression, what we did in Google Colab, what was the feature in that? There was just one feature we used. Is what it was the sleep hours. We just had one feature that was sleep hours, and the other one was output. So the feature was sleep hours in linear regression. And now here in Bangalore dataset, what we had too many features. Basically, we had square feet, BHKs, bathrooms, balconies. These are all the features, and the output or target variable was the price. So basically, we wanted all those features prediction to predict the price of that area. So that was very very well done CSV, or we created our own data sets and we gave it a tabular column. That was one part. The other part is this is the actual real part happening in today's world. We have too much of data that there is a mixture that we have tabular columns because someone might have just sat it and just gave it all the names and all. But what about these images, audio, text in general? Uh, let's say I type in article in different websites. So these are all unstructured data. They don't have a proper column like CSV format. So ML in unstructured data, we use deep learning. Like I said earlier, machine learning, you can feed that chef thousand of recipes, but how much can he remember all those recipes and cook it? He will need some other head chefs too with him to actually make the restaurant proper. So here we come to deep learning and CNNs and rest. Here, what's actually working in 2026? So images we cannot be using the linear regression and all, because one image is based on the pixels. So if I take a 64 into 64 grid pixel, a small image, 64 into 64, 64 into 64 is literally 4096. So if I take those 4096 pixels, it's like literally one pixel is one feature. Here in dataset, we just had in Bangalore dataset we had nine features. At linear regression, we just had one feature. But if I take an image of small image, it is just a small image, and if I use linear regression, that's impossible because we are looking at 4096 features. So here comes CNN. Initially, CNN. Why CNN? Because CNN is like it looks at the edges. We'll go to that. Okay, this is a framework of CNN. So if I have an image, let's take my image itself. My image is given to CNN. So what does convolution 2D do? It looks at the edges. Like okay, this if this is my image, it looks at my hair. These are the corners. These are the edges. So it takes one part of my image and it then zooms it, like it goes on filters by filter, and then it makes it into one dimension and then it gives output. If I have one more session, if I'm lucky enough to have one more session with you guys, I can just tell you how convolution neural network works, because this is how the current machine learning or whatever we are doing right now is working. So convolution neural network is a first generation, but now we have improved. But we have to know what every generation was so that we can actually work on it.
Yeah, definitely.
These
Yes,
are the
I will organize one more session a month from now.
we'll have it.
Okay. Thank you very much.
Right.
Let me ask any feedback from Aksa, Masia, and Gayatri, each one of you. Aksa, what did you learn? Any
Yes,
feedback?
sir.
Hmm.
Yeah, sir, it was very good. Actually, I didn't have that much information about AI and ML. And so this session was so informative as Sanket, he uh, gave examples with the anomaly and all. So it was very easy to understand. And when we didn't understand, even he explained. And even he helped me out to correct my error. So it was actually good. And the first thing which he had displayed, the Spotify one, it
Hmm.
was so good that it was enough to get our attention to listen to him to the rest of the session.
Yeah, it was
And
an
it was actually,
electrifying start to the session.
yes,
Yeah, especially
yes,
the music going up and down. Okay,
yeah. And
so
even the minimizing
the
thing of
I
the
think
screen.
when that volume down, that needs to be corrected. I think if that is corrected, even I liked the stretched hand for you know closing all the applications. You know, that was
Yeah,
also very
for
nice.
minimizing all the
Minimizing.
screens.
Yeah. Okay, over to Masia.
Yes, sir. It was a very informative session. Like Mariam said, like the first part itself was enough to keep us attentive. And yeah, I will be honest, I was really waiting to like get to that part, like how does that work and all of that. Uh, and yeah, we got to learn it by using the code itself, and we could see how it actually works. And yeah, we could get to use Google Colab and even Kaggle, which otherwise we would have taken days to learn because yeah. So I think this was a very informative session, and that he covered a lot of important concepts just within this short period.
Okay, Gayatri, I sorry I pulled you in late. I couldn't inform you earlier. I don't know how much you got it, but any feedback from you, Gayatri? Okay, Sanket, any feedback from you about the session? How you felt?
Uh, Actually, I thought that I would be covering everything in under 2 hours, but I just covered one part of the session. And for the first time, even I have taken sessions within the class itself. There were very few people who always interacted. So I felt that maybe I should have had a change of how I actually interact with people. So that's why I started with a hook, that the gesture coordination at the first. I thought of explaining the logic and the machine learning part in the second part, which unfortunately we don't have time. And Masiha and Mariam were great. They were responding whenever I did ask. Some people they don't even respond whenever I ask. Please tell me if you understood. Also, they will just be quiet because they'll be in some other way. So I just wanted to keep them hooked with gesture, and also I wanted to give the analogy part, because without if I just keep on bragging about the technical terms, it won't just get fixated in a head. So now Masiha or Mariam, they gave me an idea of keeping the child name as Arun. So Arun was our model. So with how I trained Arun, with what features and what labels I trained Arun, so that might have created an impact. And thank you for Mariam and Masiha. Gayatri, she joined very late, but she was there for a bit. Couldn't focus on Gayatri here. And also thank you, sir, for giving me this opportunity. If I have one more session, I have actually what I thought. If we had enough time, I thought of actually deploying an ML model by training it. So my plan was using drowsiness detection. So basically, actually it was an planned project. So the code was so much that from start to actually deploying it, I had it already. So that if we had time, we could have done it. So drowsiness detection was like, whenever I close my eyes, the system beeps. So whenever I open my eyes, so it just keeps on tracking with the camera. So that was initially planned. So that's
Okay,
okay, for maybe next time we'll have that session.
yeah, Sanket, I have a small suggestion. I
Great, sir.
would like you to publish a paper on
Okay.
this object detection for especially for counting items. You
Hmm.
remember,
Got it.
I wanted you to
Right.
become a leader in counting. Okay, whether it is
Right. Got it.
counting breaks or counting number of objects, etc. So within object detection, it is a more specialized area of research, you can say. Okay, so try to narrow your research into that area. Okay, and I'll try to support you there. Maybe co-author a paper, or present it in some conference or something like that. Okay, let's do some more
Thank you.
deep dive into this. Okay, and hopefully every month we will have I'll organize something of this nature. Okay, yeah, thank you so much, and
Thanks.
I think I'll close the call now.